When the meteorite that ended the reign of the dinosaurs crashed into the Earth, the chaos that it created, though tremendous in scale, was nothing new. And that's the honest truth. This has happened and will continue to happen time and time again. And in today's video, we're going back in time to 360 million years ago, to the boundary of the Devonian extinction, to take a look at what must have been a truly cataclysmic event that possibly caused the extinction to begin with. The Devonian is often referred to as the Age of Fishes. Massive evolutionary strides were taken, and life was really ramping up its dominance of the Earth at this time, with the first plants beginning to spread across dry land during the Devonian, forming the first forests the Earth had ever seen. And by the end of it, plants had progressed from releasing spores to becoming the first seed-bearing plants, but then, almost all of it got noped out of existence, rapidly. And in this video, we're going to take a look at why. The Woodley Crater is a name you've probably heard of if you're a nerd like me, and you love researching about ancient events that more or less decimated the globe in a matter of seconds. But this crater isn't even exposed, and as a result of this, estimates of its size are conservative at best. Some state the event might have left a crater 120 kilometers in diameter, and recent studies have provided an even larger estimate, predicting the crater could have been as large as 160 kilometers in diameter. The largest estimate, if correct, would make this the fourth largest confirmed bolide impact structure in the world, and would suggest the rock that crashed into Earth was about 5 to 6 kilometers in diameter. So if this crater wasn't even visible, then how do we know it exists? Good question. You know how it goes. Human wants resources, human drills for resources, human makes discovery. In the 1970s, this structure was first intercepted, but with the limited knowledge back then, it was only realised in 1997 during a gravity study. And you can see why. I mean, look at this, it sticks out like a sore thumb. After this gravity study, a second drill core sample was taken, and it was evident from the thin veins of shocked quartz, breccia, and melted glass that the sample was composed of, that it came from something that created a level of pressure 100,000 times greater than the atmospheric pressure at sea level, or up to 100 times greater than those generated by earthquakes or volcanic activity, meaning only a large impact event could have generated the conditions necessary to create this. This was further supported by the discovery of an extremely rare mineral called radite, which was found in a drill core sample, which was taken from the central uplift zone. So what happened when this enormous chunk of rock hit the Earth? Well, bad things. Even though the impact occurred in the extremely ancient land of Western Australia, the part that it landed in was unfortunately a shallow sea, meaning tremendous mega tsunamis were generated that would have travelled outwards in all directions, slamming into every coastline within the direct firing line before inundating vast swaths of land as it poured inland ever more. And along with this, pronounced volcanism would have been triggered en masse when contact was made, as a result of the shockwaves that were produced. These shockwaves travel tremendous distances, especially when a bolide this large strikes the Earth. So it's likely that this event, or it combined with the many other disasters that it created, might have been a catalyst to the series of pulsated extinctions that occurred in the late Devonian, possibly as a result of it triggering volcanism, from supervolcanoes to starting brand new flood basaltic eruptions. And a flood basalt event did indeed occur around the time that this impacted. The ocean ecosystem relies on phytoplankton, which obtain their food primarily through photosynthesis. Like land plants, phytoplankton have chlorophyll to capture sunlight, and they use photosynthesis to turn it into chemical energy. So when events like this occur, you can bet the sun is going to be shrouded for an uncertain amount of time, until things finally begin to settle and stabilise to some extent. This isn't only because of the impact though, it's also because of the volcanic eruptions that it triggered, almost certainly leading to volcanic winters, alongside the already terrible event that has occurred, which in itself shrouded the Earth as well as a result of the ash cloud formed by the vaporized material, which spread out in all directions. And the combination of the two would have shrouded the planet, possibly ushering in the period of glaciation known as the Fominian glaciation event. So when this bolide made contact, the first thing that happened was everything in the immediate radius of it was vaporized in an instant. Beyond that, the shockwave rippled through everything in its path as it expanded outwards in an ever-growing concentric movement, travelling unbelievably vast distances, propelling everything that it made contact with and causing untold destruction. Entire forests were destroyed, mowed down like they were little more than flimsy sticks. In the actual epicenter, the asteroid sinks deep into the Earth, like a hot knife through butter, sinking kilometers into the Earth. The solid ground that the asteroid hits gets melted into a hot plasma, losing the ability to be solid for a brief period of time, before it finally rebounded, forming this protrusion that we can see on the gravity map. The very same looking protrusion that was also witnessed in the video that we made on South Australia's Ackerman impact crater. The link to that video is in the description. Material is blasted out into space, where much of it falls back to the Earth as superheated material, sparking forest fires all over the globe, and heating the atmosphere to such an extent that heat shock occurs, which scorched the entire Earth. Some material remained in space, where it then orbited the Earth and periodically crashed back down into it, only serving to further extend the destruction for many years beyond this event. So you can see why this extinction event was so pronounced. The brief cessation of the ability to photosynthesize sunlight led to the mass die-out of plankton, causing the entire food chain to collapse, and thus the mass die-off and extinction of many species occurred. Along with everything that's been mentioned, these events are also suspected to trigger flood basaltic eruptions, which is an abnormal upwelling of tremendous amounts of fluidic basaltic magma that pours readily out of the Earth and lasts for vast periods of time without any real cessation. Events such as the Siberian traps lasted up to 2 million years, and around the time of this impact, something known as the Hangenberg event occurred. I believe this to be of flood basaltic origin, but many theories have been made. To me, when combined with the Woodley impact and the short glaciation that occurred, these events are the most logical series that tie in neatly with one another, but I could be wrong. I think bolide impacts like this really serve to show us how dangerous it is to not take these kinds of events seriously. If something like this happens today, I honestly can't even fathom what would occur. All that I know is that this is going to happen again, and when it does, I can only pray that we're prepared to deal with it before it makes contact with this beautiful planet. Or else, we'll be joining the dinosaurs in the annals of history. Thanks for watching. The late Devonian extinction was one of the worst mass extinctions that our planet has witnessed. Between 70 to 80% of animal species were wiped out. The Devonian period occurred from 419 to 359 million years ago, and, well, it was a truly fascinating time for the life that would, unfortunately, be snuffed out by the culmination of events that triggered the two major waves seen in this global die-off. As time progresses, it's seeming more and more like Australia was the site of origin for this unbelievable tragedy. And in this video, I'm going to explore the relationship between the Woodley crater impact and the supervolcanic eruptions that occurred en masse in Australia during this time period. And on top of this, there's one more event that might have been so much worse than both of these combined. Literally. If you haven't already watched the video that we made on the Woodley crater impact, then the link to that is in the description below. Alongside this, last year I made a video discussing the immense wave of volcanism that the state of Victoria experienced during the Devonian, beginning in the early part of it and peaking towards the end. All of these videos will be in the description for anyone wanting to dive into this topic further. This volcanism was to be expected to some extent, but I can't help but feel like the impact event was what led to it ramping up in its level of destruction. To set the scene, this wave of volcanism has been hypothesized to have directly caused this extinction event on its own, without the need for the Woodley impact event. It was that pronounced. But the two combined makes this bad situation a hellish one. But this isn't all. I'm still yet to make a video on the East and West Warburton impact sites, which are still being studied. The land here bears the trademark signs of a major impact event, with shocked quartz and shatter cones being evident across a vast stretch of land. It's thought that these massive bolides were actually joined at one point in time, with them splitting up just prior to smashing into the centre of Australia. If that's the case, then this would have been the largest impact event on our planet, dwarfing even the one in South Africa, which we also made a video on. These craters, when combined, are 400 kilometers in size, but since it appears that this asteroid split before impacting, it can't claim the title for being the largest singular impact event, as it was 2, not 1. Now, the reason I'm mentioning this is because this event is also dated to having occurred in the late Devonian. So, as you can see, a lot of crazy stuff went down in the 13 or so million years between, say, 359 to 372 million years ago. In Victoria, we have numerous eruptions occurring at a supervolcanic scale, and this might explain an oddity that's baffled me for a long period of time. Why did the westernmost part of Victoria suddenly become volcanically active again, randomly, after 140 million years? An impact event could certainly explain this, but in regions where volcanism was expected, such as here in the Cerberian caldera, which was near an active subduction event, or to the very east of Victoria, in Buchan, where a rift event was occurring, creating some of the most intense volcanic eruptions that this state has ever witnessed. So, in my eyes, the volcanism obviously came first. The planet was already beginning to be greatly affected by the massive amount of volatiles that were being released, with volcanic winters being more or less commonplace around this time because of how explosive the events were. Then we add 2 major impact events on top of that, one that's confirmed, and the other looks to be spot on as well, as shocked quartz and shadow cones can only be formed by bolide impacts or nukes. And obviously, the fissures of the Devonian weren't nuking each other, or were they? The Woodley impact event is dated at 364 million years ago, plus or minus 8 years. The late Devonian extinction began 372 million years ago, so if we added 8 million years to this, well, this coincides almost too perfectly. The Warburton impact events aren't as concise, with a large gap occurring in the dating, with it being estimated to having occurred between 300 to 360 million years ago. For the sake of this video, let's assume it occurred 360 million years ago. So now that we have the dates laid out, let's go back to the volcanism. In Victoria, the volcanics here were raging, but they peaked in the late Devonian, and by peaked, I mean they kind of went absolutely insane. Every part of the state was releasing massive explosive eruptions. Mount Macedon, Mount Dandenong, the Archeron caldera, dozens of calderas in the rift zone, and a strange reoccurrence of explosive felsic eruptions in the ancient Cambrian zone of Victoria, in the westernmost part of the state, were all active at this time. And because much of Victoria was still submerged beneath a shallow sea, many of these, including the largest supervolcanic eruption released by the Cerberian caldera, occurred in a submerged state. They weren't released in the open air, changing how the volatiles released affected the ecosystem. There's a mention that when this extinction event occurred, it did so in pulses, and alongside these pulses were sporadic periods of glaciation events that would come and go, seemingly at random. These fit in perfectly with what would happen if major volcanic eruptions were occurring, due to the volcanic winters they produce. But in general, the extinction is separated into 2 major events. The Frasnian-Furmenian event, which started this extinction off at the date of 372 million years ago, saw the extinction of 50% of genera and 19% of all families. On top of this, a glaciation event occurred in the late Frasnian too, which serves to corroborate our speculations to some extent. I believe the Woodley impact event might have been the catalyst for these eruptions to flare up in their level of destructivity 372 million years ago. But it's not only the explosive side of things. Massive, and I mean massive amounts of intrusives penetrated Victoria around this time. And it's possible that this was due to a gigantic upwelling of magma that rose up from the mantle, spurred on by the shockwaves produced by this cataclysmic event, or maybe that was just bound to happen. Either way, we need to take everything into account. So 372 million years ago, the Woodley bolide smashed into Western Australia and caused untold devastation. In my opinion, it triggered many of the volcanoes in Victoria, and obviously around the world, to erupt. But my focus is on Victoria. I believe these eruptions occurred in tandem with the impact event, and it led to a literal snuffing of life due to the collapse of ocean ecosystems, as the sun was blocked for an extended period of time, owing to the volcanic volatiles, combined with the unbelievable amount of debris that was catapulted into the stratosphere and beyond by the asteroid impact. And this also triggered a major flood basaltic event too, which only served to add more fuel to the fire, so to speak, by releasing even more volatiles and further preventing the ability for the sun to properly penetrate the Earth, meaning nothing could photosynthesize. After this, a glaciation event occurs, and during this time, volcanism continues to rage on prolifically across Victoria. Now, it's possible that this volcanism was all that was required to trigger the second and last major extinction event, which occurred 360 million years ago, known as the Hangenberg event. But if the Warburton meteorite did actually smash into Western Australia at the 360 million year mark, then it's obvious that the same thing that happened at the 372 million year mark occurred again, only on a much grander scale than it did with Woodley, as Woodley is literally dwarfed by just one of the Warburton craters, let alone two of them. One thing is certain, something caused a deadly level of ocean anoxia. That is, a lack of oxygen prohibiting decay and allowing the preservation of organic matter. This, combined with the ability of porous reef rocks to hold oil, has led to Devonian rocks being an important source of oil, especially in Canada and the United States. The Hangenberg event can be recognised by its unique multi-phase sequence of sedimentary layers, representing a relatively short interval of time with extreme fluctuations in the climate, sea level, and diversity of life. The entire event had an estimated duration of 100,000 to several hundred thousand years, and this would fit in line with what would occur as a result of volcanism and an impact event. But on top of this, flood basaltic eruptions did occur during the Hangenberg event too, and as you can see, the list of flood basaltic eruptions occurs perfectly in tandem with the timing of the Woodley impact and with the later Hangenberg event. Both had associated flood basaltic eruptions. This, in my eyes, is a strong case to argue regarding what caused the Devonian extinction. And this is just taking one state in Australia into account, because I know this place like the back of my hand. This doesn't take into account all of the other subduction or tectonic rifting events that occurred during this time, which had volcanoes that definitely would have gotten triggered by either one of these impact events. But what I have presented is enough to completely mess the world up, and to create the conditions necessary to form an extinction event at a scale as disastrous as the one witnessed during the late Devonian. What do you guys think? Do you think the Warburton impact events were what created the final purge in the very late stages of the Devonian, or do you think something else caused this? Let me know your thoughts. So this is my attempt to connect the dots to explain one of the worst extinction events that our planet has witnessed. What a terrifying time to be alive. Nowadays, the volcanoes that release these cataclysmic scale eruptions can be seen all around Victoria, from the picturesque Mount Macedon to the Cerberean caldera. But behind the beauty is a fiery and destructive origin. Thanks for watching. The Friedewort impact structure is the largest verified impact site on Earth. This event was unimaginable in its scale of destructivity. The crater itself has long eroded away, but even with that, you cannot hide what this event did to the surrounding rocks. In its heyday, it's estimated that this crater was between 180 to 300 kilometers across when it was originally formed. If it was 300 kilometers across, that would mean it is double the size of the Chicxulub crater, which was formed by the collision that we associate with ending the reign of the dinosaurs. So in this video, we're heading to South Africa to look at the largest single impact site on our planet that we've discovered thus far. The Friedewort asteroid was an absolute monster. If it hit today, we can say goodbye to life as we know it. It was so massive that it's estimated to have been one of the largest asteroids to have struck our planet since the Hadean Eon, some 4 billion years ago. With that being said, this impact event occurred around 2,000 million years ago. How do we know? Zircon dating. Radioactive decay is very reliable, and these tiny little crystals are like the mineral versions of a USB drive, in that they store very reliable data within them, and it allows us to successfully date these types of events with great accuracy. The asteroid itself has an estimated size of between 20 to 25 kilometers and was traveling at an intense 15 to 25 kilometers per second. As per usual, we see the typical central uplift dome that we saw in the videos that we made on the asteroid that hit South Australia and in the video that we released yesterday, where we covered one of the largest verified impact sites on our planet that occurred in Western Australia. This central uplift dome forms as a result of a rebound that occurs post-collision. When these massive asteroids initially make contact with the Earth, the force is so tremendous that it literally melts the crust in an instant and temporarily turns it into a hot plasma, as the asteroid itself dives kilometers into the Earth. After the Earth has been sufficiently pounded, the plasma rebounds, cools, and solidifies into rock again, leaving behind these noticeable protrusions right in the middle of impact centers. In South Africa, this zone of uplift is known as the Vredefort Dome, and it consists of a partial ring of hills that are 70 kilometers in diameter. Originally, people interpreted this place as having a volcanic origin, until the discovery of shatter cones and shocked quartz in the 90s. Both of these are telltale signs of extraterrestrial impacts, as the force required to form them far exceeds the force that could be applied by any natural process that's present on Earth. Only an impact event, or a nuke, can create the types of pressure necessary to form these two phenomena. The cool thing about this place is it's a multiple ringed impact structure. Now, because this is very eroded, here's a great example of a complete one on the moon Callisto. As the name suggests, multiple rings were created as the force of the impact radiated outward, and during this event, the distortion of the Witwatersrand Basin, the Ventersdorp lavas, and the Transvaal supergroup occurred. The rocks form partial rings around the impact structure, and because the rocks of the Witwatersrand are so erosion resistant, with them comprised of silica-enriched rocks like quartzite, it's visible on Google Earth in present day near the impact center. The area where this asteroid struck is actually one of the oldest cratons to exist on our planet, with it being around 3.9 billion years old. So it appears as though this was dry land when this event occurred. But it's obvious that this didn't need to impact the oceans to cause tsunamis, as the earthquakes and pronounced volcanism that would have been triggered by this event from the enormous pressure that rippled outward in all directions was more than enough to bridge that gap. I can imagine earthquakes occurring at a magnitude far, far beyond anything that humans have seen during this, shaking literally the entire planet. Not one single stretch of land was spared during this cataclysmic situation, and much like yesterday's video, the destruction it wrought came in many ways. Firstly, this event would have made its presence known in the night sky, many months before it arrived, beginning as little more than a dot, and growing in size, bit by bit, as it edged closer and closer to our planet, until, one day, it suddenly appeared in a menacing way, burning bright at a size that was as large as the sun when viewed from the ground. But obviously, nothing existed back then to look up and see it, as life was more or less microscopic at this point. For reference, the Chicxulub asteroid was larger than Mount Everest. This was, at its highest estimate, double that. So imagine something double the size of Everest greeting you one fateful morning. Terrifying. As it makes contact with solid ground, a blinding flash of bright light illuminates the sky, and it grows larger and larger in size with each passing moment. The thermal radiation released by the explosion travels outward in an ever-growing concentric ring. If animals and plants were alive, they would be instantly vaporized by this. But since they aren't, only rocks were present to bear witness to this and to be blasted by the shockwave that followed. But we have everything else. Volcanic eruptions got triggered as shockwaves passed through every bit of the Earth, affecting areas on the opposite side of the planet. The entire planet shook ferociously, seemingly without end, and, as mentioned before, when these events occur, the crust where the asteroid hit is temporarily turned into a gooey, liquid, hot plasma, as the asteroid forces its way deeper into the Earth. And after that, this hot plasma rebounded, temporarily forming a mountain 20 kilometers high before dropping back in on itself and forming the central uplift zone that we see today. An astronomical amount of material is mass ejected out of the planet and into space, propelling Earth debris as far as Mars and beyond it. Much of it, however, falls back down to the Earth, and in doing so, it superheats the atmosphere, creating a situation known as a heat shock, where the air in the planet literally becomes superheated for a short period of time, further scorching everything. Volcanism in the form of supervolcanoes and flood basaltic eruptions would have definitely followed this event. Now, just to nerd out a bit, if this asteroid had have landed in a deep ocean, at its most conservative estimate, a 2-kilometer high mega tsunami would have been generated. Can you imagine how horrifying, yet awe-inspiring that would be to witness? Whew, damn. After this event, from space, Earth would have looked like hell. Literally. It was one way, only moments prior, and now it's been transformed into something that would have been unrecognizable from its former self. And this would have been how it remained for many years after this event, as Earth slowly healed from the wounds inflicted. Meanwhile, any form of life back then more than likely avoided almost all the disastrous things that were triggered by this event, with it chilling out at the bottom of the ocean floor, chowing away on the gases that were being churned out of volcanic vents non-stop. And so, this is the story of the world's largest known and verified single impact site. Thanks for watching. The Permian-Triassic extinction occurred 250 million years ago, and is believed to be the most significant and profound extinction event since the origin of complex multicellular life. But along with this Armageddon occurred the beginnings of the separation of two landmasses that, before this, had been joined up for well over 300 million years. Those are Australia and Antarctica. They joined up during the formation of Gondwana. But the detachment of these two continents may have had an explosive catalyst. So, in this video, we're going to take a look at the relationship between the massive impact crater in Antarctica and the parting of it with Australia. Buried under 800 meters or 2,624 feet of ice lies a magnetic anomaly that has hinted at a possible bolide impact since the early 1960s, when the first magnetic images were made available to scientists. In 1976, the hypothesis was detailed in a paper, and the evidence cited included a sizable negative gravity anomaly coincident with a subglacial topographical depression. The measurements were 243 kilometers or 151 miles across, with a minimum depth of 848 meters or 2,782 feet. These claims were challenged by another scientist in 1979, who was then disproved almost 30 years later in 2010 when a new paper reclassified the Wilkes Land anomaly from being a possible impact crater to being a probable impact crater, based on the evidence provided by the most recent paper as mentioned earlier. Further investigations have pointed to an impact event including a marked thinning of the crust underlying the topographical depression, with an estimated thinning of between 7 to 10 kilometers or 4.3 to 6.2 miles of crust occurring during the impact. That's pretty crazy to think about. Much of this was melted down into a plasma upon contact and catapulted out in all directions, with much of it being flung out into space, where it would then fall back down to the Earth, becoming superheated during the re-entry of the atmosphere, contributing to even more chaos and destruction in the process, as this superheated debris would have sparked significant forest and grass fires planet-wide. This asteroid impact is also linked to the unbelievably long-winded and cataclysmic 2 million year long Siberian Traps flood basalt eruption, as the Siberian Traps are antipodal to the point of impact, meaning they're on the opposite side of the Earth from where this bolide struck. Now, this is a contentious issue. Antipodes are still in the hypothetical stage, because it's hard to test what would happen on the opposite side of the planet from where a large rock slammed into it without, there being a large rock slamming into it, and us surviving. But most scientists know this is most likely what's going on, as the energy from these events needs to go somewhere. And the opposite side of the planet from the spot where it struck isn't out of reach from being affected. If these events can thin the crust by 7 to 10 kilometers in seconds, I can only imagine what occurs after the initial impact regarding the transference of energy. It's been speculated that if this was a crater, then the rock that created it was 4 to 5 times wider than the Chicxulub impact event, which took out the dinosaurs. Without a doubt, this type of event would have caused a major planet-wide earthquake, achieving a magnitude beyond anything that Earth's natural tectonic process can reach. So it's definitely possible that this is the impact that set the gears in motion for what is perhaps among the worst volcanic events to occur on our planet, with massive amounts of volatiles being released, affecting the climate of the entire world, and causing negative and potentially fatal impacts to areas near and far from Proto-Siberia. Now, speaking of the point of impact, this is the location of Wilkes Land Basin, where Australia was joined to Antarctica when this hypothesized event occurred. Now, researchers speculate that the purported impact and associated crater may have contributed to this separation by weakening the Earth's crust at this location. And this is actually a relatively common theme. I've read about this often, where an impact event is associated with a rifting event. For example, the Chicxulub impact that wiped out dinosaurs is associated with India's Deccan Traps flood basaltic eruptions, which followed a similar timeline and eruptive journey as the Siberian Traps did some 190 million years before it. So I'm a big proponent of the antipode hypothesis, and I find it to be fascinating. Generally, the actual physical causation for the separation of a continent is the upwelling of a mantle plume, and if the crust is thinned, magma will rise. And when magma rises, the lands on either side of it get pushed away from one another at an ever-increasing rate. These events also tend to propel tectonic plates forth faster than the average speed they are known to drift at each year. The tectonic plate that Australia rests on is one of the fastest moving on our planet, and it could owe that to this event, and the associated mantle plume that preceded it. Another interesting thing to note is that this impact event might also be associated with the massive supervolcanic complex that erupted in New South Wales around this point. And this complex in its own right is associated with the Permian-Triassic extinction because of just how intense it was. This bolide and the associated shockwaves propelled forth by its collision may have actually led to the eruption of many of the supervolcanoes that were present there back then. I've already made a video about this fascinating place, and it's a relatively new discovery too. You can find a link to that in the description. When Australia and Antarctica began to split, a rift valley formed, and this disturbed some of the land around the hypothesized crater. But aside from that, if we were to go down there and get a sample of the rock, we'd be able to ascertain whether or not this is a 100% guaranteed impact crater. These, if only we could get to it, scenarios are common, and it does my head in. This is the only thing that's stopped researchers from getting a sample of the Burckle crater, which lies deep within the Indian Ocean. And as recent events have shown us, the deep ocean isn't exactly hospitable to human life. So until then, we have to rely on geophysical methods to ascertain the likelihood that the Wilkes Land topographical depression has an origin directly related to an impact event, along with other techniques like searching for ejecta and such. So what do you guys think? Do you think this is the cause of the split between Australia and Antarctica? Or was it just an inevitable thing bound to happen either way? Let me know in the comments, and thanks for watching.
Lake Acraman is a shallow saltwater lake located in South Australia. In this arid area of Australia's outback, this seemingly innocuous structure has existed here for around 580 million years, after a massive meteorite suddenly smashed into this part of the world, creating untold devastation in the process. Massive tsunamis were created from this impact event, and the fallout from it would cause far-reaching consequences that would alter Earth for decades to come. Today, we're going to introduce a new tool to this channel so that we can take a better look at Lake Acraman and the impact event that created it. Alongside this, as per usual, we'll also take a look at the magnetics to better define this structure. And I believe there may exist one or two large volcanic calderas of a completely unrelated origin existing right alongside Lake Acraman, which I'll also segue into briefly as the video progresses. Before we get started, I just wanted to thank everyone who donated to the channel's PayPal. Thank you all so much. I've just enabled YouTube memberships, so consider joining for only a few dollars a month by clicking the join button down below. Or if you'd prefer to do a once-off donation, the link to the channel's PayPal account will be both on screen and in the description. I'm looking to scale this channel up so that I can release more content of a higher quality, so every donation or membership is appreciated beyond measure. In time, I'll open up a Patreon too. Let's get into it. Present-day Lake Acraman is hard to read. It's been significantly eroded and is different in terms of how it looks compared to other more circular meteorite craters that exist in Australia and around the world. such as this infamous meteorite crater in Wolf Creek. But make no mistake, this area is without a doubt a massive impact site. In fact, it's actually one of the largest that's been found anywhere on the world. The rock that this meteorite smashed into was primarily lava created by a supervolcanic eruption that took place here 1.6 billion years ago, and it threw this rock very far from the site of impact, with it being launched well over 500 kilometers away during the event. The original crater is 90 kilometers wide, and the velocity that this meteorite struck the Earth at was around 25 kilometers per second. The tsunamis generated by this event would have been unbelievably massive, at least 500 meters in height, with it more likely being closer to 1 kilometer in height. When we examine the rock found directly within the crater, we see the telltale signs of a massive meteorite impact. The two qualities I'm about to discuss aren't found naturally anywhere else on our planet. They are entirely extraterrestrial in their origin and their presentation. The pressures required to form both of them do not occur on the surface of the Earth, and aren't able to be explained by other mechanisms. The first is shatter cones, a very distinct conical feature found in these rocks. The second is shocked quartz grains. These very fine planar fractures are created in tiny quartz grains after they have been subjected to immense pressures. When we fly over Lake Acraman, we see the outcropping of the ancient Gawler Ranges volcanic rock, amongst much more recent lake deposits. As previously mentioned, this impact crater isn't the simple bowl shape often seen and associated with meteorite impact craters, and as a result of this, it's known as a complex crater, because it has a complicated surface with variations in elevations. The reason for this is because over time, the surface has eroded several kilometers below the original crater floor, exposing the more erosion-resistant rocks in the process. When we look at Lake Acraman under the magnetics, we have a further telltale sign of an epic asteroid impact. The center of it is protruding, and I'll explain the reason for this shortly. Life did exist at this point in time in the form of acritarchs, which are small organic microfossils known to exist in the fossil record starting around 1.8 billion years ago and existing all the way to present day. And when this event occurred, a dramatic change in a type of these acritarchs was found in the rock record from this time, which coincides with the estimated occurrence of the Acraman impact, showing just how far-reaching the effects of this event might have been. So what actually happened when this meteorite struck Earth? Well, as the asteroid made impact with the shallow Adelaidean Ocean that existed here 580 million years ago, a blinding light would have flashed forth as the muddy ocean bedrock succumbs to an unimaginable level of heat and energy. It's literally vaporized instantly upon contact when this gigantic extraterrestrial rock makes impact. The meteorite penetrates through kilometers worth of sedimentary material, ushering forth a level of destructivity that stretches far beyond any weapon that humans have ever created. An ever-expanding shockwave is seen as a white sphere that stretches forth in all directions. This shockwave produces massive tsunamis, and the thermal radiation emanating from it travels forth at the speed of light, sterilizing everything in a massive radius around it. The energy of the impact dives into the Earth's crust like a stone being thrown into a pond. The solid bedrock in the immediate impact site loses the ability to be solid, as the meteorite vaporizes it upon contact. This bedrock is melted into a hot plasma, as a 90-kilometer wide crater is created. Just for reference, the asteroid that wiped out the dinosaurs created a 100-kilometer wide crater, so this event is just short of that kind of massive event. The shallow Adelaidean Ocean is thrust back in all directions for hundreds of kilometers, and the liquid consistency of the Earth's crust begins to solidify again and bounce back in a rebounded state, forming this protruding mountain that we can see on magnetics today. Material is blasted from this once peaceful shallow ocean out into space, where much of it then falls back to the Earth as superheated debris, which comes crashing down back into the Earth at incredible speeds. Some of this material will orbit the Earth for thousands of years before it crashes back down though, so not all of it immediately fell back down to the Earth, and some of it may have even reached as far as Mars. But in general, most of it came straight back down. And this is where things took a turn for the worst, which was something you probably thought was impossible at this stage. But it isn't. Because as material falls back to the Earth, it reaches extremely hot temperatures. This material heats up the atmosphere, creating a heat shock, scorching the entire Earth. No trees existed at this time, so no real wildfires were created, but this event would have been felt everywhere on Earth. Earthquakes of a tremendous magnitude 11 would have been produced, and it's possible that this impact event caused immense volcanism on the opposite side of the planet from where the impact site occurred, most likely in the form of flood basalts. It also more than likely caused many volcanoes to erupt, as the shockwaves and earthquakes would have created faults, fractures, or conduits, allowing magma to rapidly ascend, or it might have just raised the pressure levels inside the magma chamber itself, creating a catalyst for violent explosive eruptions to occur. And this would have been both near and far from where the meteorite struck, as the shockwaves travelled in all directions. Much like a volcanic or nuclear winter, a gigantic ash cloud formed by the vaporized material spreads forth in all directions, eventually shrouding the entire planet in a blanket of solar reflecting aerosols, possibly plunging the entire planet into a deep freeze and ushering forth an era of glaciation. This is where the Acritarchs got hit hard. This shrouding of the Earth temporarily halted photosynthesis, leading to a mass die-off of plankton that the entire ocean ecosystem relied on to survive. This is most likely why there was a significant variance in these organisms pre- and post-impact. When this meteorite made contact with the Earth, the ejecta that it threw up into the surrounding area eventually settled into the mud on the surrounding sea floor. This ejecta is associated with an iridium anomaly, suggesting it had been contaminated with extraterrestrial material, aka the meteorite. Nowadays, this 20-kilometer diameter lake is a shadow of its former glory. Over 2.5 kilometers of the original crater floor has been eroded. We can find the ejecta associated with this event in many places far away from the impact crater. At Bunyaroo Gorge, we have one example of this in the rock layer known as the Bunyaroo Formation. This is a sedimentary layer of shale, which is a grey-coloured deep-water sedimentary rock formed in a marine environment. In these rocks, we see a very sharp break, and distinctive alien rock fragments appear in the rock record, which should not be here. These are from the Gawler Range volcanics, which were released far away from this location 1 billion years before the meteorite struck. They are pieces of volcanic rock from Ayers Peninsula, which have been tied in with this sedimentary shale as a result of it landing here after being launched far away from the original impact site. The Gawler Range's volcanics is a very distinct and beautiful pink rhyolite that cannot come from this area. There is no logical source, and it's chemically identical to the Gawler Range's volcanics, which travelled 300 kilometers to reach this site. It's safe to say that geologically speaking, this was an extreme event. So that's the story of the Lake Acraman impact crater, one of the largest meteorite craters to exist on our planet. When we fly low and over the middle of it, a quick 360-degree rotation clearly shows the outline of this massive impact crater, with it ending where the mountains begin. It was a truly extreme event that had immense implications for evolution and for the Earth at large. One day, another Acraman-sized meteorite is going to travel our way, and these events will repeat themselves once more on this planet. Let's just hope that we're prepared before that happens. Thanks for watching. Don't worry, I won't leave you hanging. I know I mentioned I might have spotted 2 calderas. I suspect that these might be associated with the Ardea dacite, and if not, then it might be one of the spots where the strange and very unique Gawler Range's volcanics was released, which I'll be making a video on real soon. There's a structure that looks to be a pretty visible ring dike here, and another that's only really visible on magnetics. I'm not sure if they're calderas or intrusives, but I'd say they're worth looking into further, and I definitely intend to do that one day when I go there in person. I hope you enjoyed this meteorite topic though. I've been reading your comments and yep, I'll begin making videos that covers events that occurred in other states in Australia other than Victoria, and I'll be beginning a New South Wales series shortly. Thank you all for leaving your comments. It's been a chaotic few weeks for me as I deal with some personal stuff. but I'm trying to reply to as many comments as I can. My work hours are a little insane, and it's become a little difficult with the hundreds of comments and emails that I'm receiving daily, but I will try to get back to as many of you as I can as soon as possible. Big things are due to happen in the near future, as this channel continues to grow. If you found this video interesting or fascinating, then you're probably a little into earth science or science in general. I release new videos once a week, so consider subscribing, and if you'd like to help the channel out, the best way that you can contribute and make a huge difference is by sharing our videos around first and foremost, followed by liking the video to let YouTube know we're doing something right. Thanks again for supporting the channel, it really does mean the world to me, and like always, I'll see you all real soon.